Hi, the topic of today will be about functions. So in one of the previous videos, you saw about sets of number and some notation about the sets. But now what we're interested into are some interaction between sets. More particularly, what we want to do is to apply some transformation on some elements of a set to go to another set. So we'll do that thanks to the functions. Let's start with a simple example of the concept of mapping. Suppose that you have different characters in a village, asterisk, obelix, etc., and then finally panoramics. Then what you're doing is that you want to do a lottery in which one person would win. Then what you can do is that you can assign for each of these characters a number. So asterisk got the number 5, obelix got the number 12, and finally panoramics has the number 20. This operation of assigning some number to a certain character corresponds to the idea that we're using for the functions. Another simple example, the quadratic function. So again, what we're doing is that I give you a value, a real value for x, and then what you have to give me is some value of f of x. And the quadratic function here, x squared, corresponds to the square of a given number. For example, if I give you 3, then you return me the number 9. Be careful with your notation. So I don't like to use y to designate the image of x. The reason is that if I simply show you this expression, you might wonder, is it an equation to solve? It is not clear. So what I prefer to do is to use f of x to design the image of the point x. So for me, it's really clearer. Now, there's a missing thing. So what happens if x is smaller than 0 in this function? So I'll give you a couple of seconds and try to think about it. Well, if x is smaller than 0, the function is not defined. So for this reason, when you're mentioning a function, I highly recommend you to specify from which set is the mapping. So it's from a set to another set. So we'll see that in the next minute. Let's go for some formalism. So like I've told you, we have to mention the sets for the function if possible. So f is a function from a to b is expressed symbolically by these two ways. So these are equivalent and these should be easy to understand. So f designates the function and then the arrow designates the mapping from one set to another. What is a and b? So a corresponds to the domain of the function. So the domain is the sets of value that the independent variable can take. So if you have f of x is equal to square root of x, the domain is the positive number. And b corresponds to the image of the function. So what is the image of the function? It corresponds to the set of value that the image of the variable can take. So for the square root of x, it only gives positive value in our case. So positive real numbers. Here is another way to write the function instead of using the equality sign. You can just do a mapping from x into f of x. So f transform x to f of x is expressed symbolically in the two following ways. So here you notice that the arrow is slightly different. It's simply used to designate the mapping from one number to another one. So here for the second expression, the f above the arrow can be a little bit trivial, but imagine if you have x mapped into x squared, then f designates the function, so it's fine. Okay, the important characteristic of a function is the following. The value of f of x is set only for any element x of the domain. So what does it mean? It means that if I give you a value of x for your function, you might give me one and only one value for f of x. So in which situation we might not encounter this. Think about a circle drawn on a plane. If I give you a value of x, there are two values of y's. And similarly, if I give you an ellipse on a plane, what happens if I give you one value of x? You will have to return two values of y. So these are not functions. Okay, so this is almost the end of the lesson, a small exercise to summarize and to test yourself. So you have the function f of x, which is equal to square root of x. So the question now in two parts. What is the domain? First part. Second part, what is the image? So pause the video and think about this. So if you found it, congratulations. If not, no problem. So both of the domain and the image corresponds to the same set. Both correspond to their positive real numbers. Okay, I hope you enjoyed the lesson. Thank you. See you soon.